Hello, good morning. Welcome once again. Welcome everyone. Welcome. Today we will continue from where we left off last week. I hope you can hear me.
Yes, sir.
Yep.
Okay. So let's review a little bit. So last week, I think majority of us were here on the call. We looked at some of the fundamental things, the nitty-gritty things we have to know when we want to do C++ programming, right? So for example, I remember us looking at how to collect user input, right? What's the keyword we use to collect user input? The keyword. What keyword do you use to collect user input? If you want to take input from a user, what word do you type to take input from a user? Okay, so I have something in the chat. Oh, Alfred, I'm expecting the keyword. Yes. Okay. CN, yes, CN with a small c, not a capital C. Okay. So please take note of that. Okay. So we use CN. And then if you want to print something to the screen, right, what word do you use? What keyword do you use if you want to print something to the screen? Printing something to the screen.
Yeah, sir.
C out. Thank you very much. And then you use the less than, less than. Yes, thank you. Thank you very much. We also learned about variables, how to create them. And we said that variables have a name. The name of a variable is called an identifier. Okay? So variable names are called identifiers. So from henceforth, when I say identifier, your mind should not go anywhere, but your mind should be on the fact that we are talking about variable names. Okay? In our review, we also said that in order to name things, you can't just give a variable a name. Okay. Yes, you can give things name. Okay. But you can't just give a variable or class or a method a name. There are rules because it's a programming language. It's not like English that we can speak and then make words as we go. In the programming language, the computer has a specific rule it follows. And so when you are naming things in C++ and other programming languages, you must be mindful of the rules. So we said that the rules for naming identifiers is that you can use any character of the English alphabet, okay? So you can use uppercase, lowercase, you can mix them up, you can type a word which is useful or a word which is not really legible. You can just type Z, 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 Z. It doesn't really matter. Okay. So you can use any of these characters. You can also use underscore, the underscore character. You can also use any number, any combination of numbers. The only rule is that you must not start the name with a number. Okay. So when you create an identifier, which is the name of a variable or anything in the programming, you must not start it with a number. If you are starting something with a number, then it means it is not an identifier or it cannot be an identifier. So please be mindful of this one as well. Okay. We learned a few things about data types as well. We said that there are different kinds of data, okay? Different kinds or types of data, okay? So data types are the kind of data that the computer, we can enter into the program, okay? So we have integer. What do we use integer for? Integer. What do we use integer for?
Right whole number, sir.
Whole numbers.
Write whole numbers. So if you are writing a number without a decimal point, in the programming, we call them integers. Okay. Then if you are writing a decimal number, what do we call them in the programming? What do we
Floats.
call? float or
Float. Boolean.
okay.
Hey, sorry. Doubles.
Yes, float or doubles, depending on the size of the decimal. Okay. If the decimal is large, it's called a double. If the decimal is small, it's called a float. Okay. Then what do we call characters, single characters on your keyboard? Yes, who's helping us? Please, another person,
Strings.
single characters.
Characters.
We are just reviewing. Pardon?
Character.
Is it the same person? Is it only one person on the call?
No, sir.
Yes, so it's called car or characters. Okay. Yes. And then how about true or false values? True or false values?
Boolean.
Thank you very much. So when we have true or false values, or we are doing any computation which requires true or false values, our mind should be on the fact that we must create a Boolean. We use B-O-O-L, bool, to represent Booleans, okay? Then we learned about modifiers. We learned that in C++, you can have a modifier in front of the data type. So we learned about a modifier called short and a modifier called long. Okay, so usually, and then a modifier called signed and a modifier called unsigned. Okay, so usually if the number is, if what you want to do involves only positive numbers and you don't need a negative number, remember, let me come back to this. Remember, the computer, the most important or precious thing in your program is space. Okay, space is the most important thing. And this int, float, double, double, Boolean, and the rest, they have a particular size that have been assigned to them by the compiler. Okay, so what we want to do is that, for example, if you have an integer, because integer can be positive or negative whole number, the size, which is the 4 bytes, which have been assigned to integer, is divided into half. Half represents negative numbers and half represents positive numbers, so that you can get the range of negative and positive numbers. But if you don't need any negative number and you only want to use positive numbers, then we must not waste the half. So if you want to force the computer to only do positives, then we use unsigned. Okay, we use a modifier called unsigned. So the modifier called unsigned forces only positives, so that all the 4 bytes, the range of 4 bytes, is used for positives. Okay, so that you don't have to worry about negatives in there. But if you use signed, then it means we divide the number space or the number line into 2, right? Half will be positive, half will be negative, and 0 will be in the middle. Okay. Then when we say short simply forces the integer or forces whatever you put it in front to reduce the size to the smallest size possible. So for example, integer is 4 bytes, right? Now, if you type short is also either 2 bytes or 4 bytes. Okay. If you type long is 8 bytes. Long gives you more space, so you can store more. Okay. So these ones are like modifiers. If you put the short only, if you say short amount, by default, amount is an integer. Okay. So please take note of these differences. If you see any of this, don't be scared. We've already treated all of this. Today, we are going to look at another important aspect of our programming, right? We are going to look at control structures. You are very much familiar about control structures. And so today we're going to look at control structures, and we are going to delve deep into decision control structures. Depending on how we assimilate this material, we might divide this lecture into 2 halves so that we can do half today and then half the next week. But I'm still going to continue. When we get to 9 o'clock and it's time and we are not done, we will continue the rest next week. Okay? So let's move on to what we came. Now, remember, we said that in programming, every statement or how we construct our program can be put into one of three important groups, okay? Important groups of statements. We call this groups of statements control structures. Now, the three important groups of statements can be mixed in any way or the other in our program to create any program. So every single program you are seeing on your phone, on your laptop, on an AI engine, on something belongs to one of three important groups of statements. When you master the logic behind these groups of statements, you can construct any program at all that you want. Okay, so the three groups of statements are sequential control structures, selection control structures, repetition control structures. Now, when we say sequential, we are referring to all the statements or groups or keywords or constructs which execute one after the other. They execute in a manner we call sequential order. They are sequentially ordered. Okay, so one statement runs, then we go to the next one, then we go to the next one, then we go to the next one. Usually in these types of statements, there is a keyword in there, there's something we are doing, there's maybe a command we are issuing or something that we are doing. There is no branching whatsoever, or there is no repeating whatsoever. It's just one statement in there, and we do that statement and we move to the next one. We call this kind of statements sequential. So the C out that you saw, the C in, the int something something, double something something, creating of the variables, all those types of things we saw earlier are all grouped under sequential control structures or statements. Okay, so like I was saying, the statements run one after the other. I hope you can see my slide. Hello?
Yes, sir. Yes, sir.
Okay, good. Please, if you can't see anything, you let me know, okay? Then the next group of statements we know are called decision, or we can also call them selection control structures or statements. Now, these statements allow your program to evaluate a condition, and depending on the answer to the condition, run one or more expressions. Okay, so that's why we call them selection. So they select one or more options, depending on whether a condition is true or is false. Okay, so usually you implement these ones with statements like the if keyword or statements which contain the switch case keyword. Okay, so we have a test that we normally will check. There's a test we will check, and then based on the answer to the test, we can either say yes, okay, or we can either say no. Okay. Is there a question? Let me check. Sorry, let me check the chat. Who is? Oh, sorry. Yeah, I think that's not meant for me. Okay. So yes, so these are called selection or decision control statements. Now, we have seen examples of these before. Remember, we did our course earlier, Introduction to Programming or Structured Programming, and we learned about statements like this. The if statements usually instructs the computer to check a condition. And then if the condition is true, we will come and run the statements within the if statement. Okay, so this one, for instance, if age is anything above or equal to 18, we will see out or we will run this eligible to vote instruction. Okay, but if age is not above or equal to 18, we will not do anything. We will simply jump out of this. Okay? So these types of statements are called selection or decision control statements. Then the last but not the least are the repetition control statements or structures. These types of statements permit or allows your computer to repeat some series of statements for some number of times. Okay, so for example, I want to print something, I want to print a receipt. Every time somebody buys something at the mall and then you take it to the counter, the receipt is printed. So it's just a repeat. Now imagine we have to program that thing one by one. You can understand that it will be difficult to program that thing one by one. So one day, if there are 1,000 people at the counter, you have to program the thing 1,000 times. And the other day, if there are maybe 5 people, you have to program the thing 5 times. So if you need to repeat something, there is a block of code or statements which allow you to force the computer to repeat something for some number of times. Okay, so we call these ones repetition or iteration or loop control statements. Okay, examples of these statements are the while loop, we have the do while loop, okay, then we have the for loop statements as well. These ones cause the computer to repeat something for some number. So we see in the example that you are seeing over here, you see a for loop with the initialization, the test condition, and then the loop update condition. Now, because of the for loop, we are going to repeat this statement for this number of times. Okay, so long as I is less than or equal to 5, we will print the number inside I. Okay, so they usually do a test. They usually initialize a counter variable, do a test, and if the test is true, we go and run the statement and come and repeat this process again. We'll keep running the statement until the test is false, where we go out of the block. Are we okay? I hope we are all in the clear. I think by now most of you are very much on the same page as I am. Okay. Now, today we will focus mainly on C++'s decision or selection control statements. So like I explained earlier, the decision or the selection control statements allow the program to evaluate an expression and then run or decide to do one or more of the options. Okay. Usually the outcome of the condition or the test determines which of the expressions that will be run. Okay, so please take note of that. Sometimes we have one that we only run the test if it is true. We have another that we run the test if it is true, and another we run the code if it is true, and then another one that we run the code if it is not true. Okay, then we have one that we can do multiple tests at the same time. Okay, so let's look at the various kinds. So in C++'s decision control statements, we have the if, which is mainly if statements, and then we have the switch case statements. Okay, now amongst these two, for the switch case, it's very simple. It's just one block. It's called the switch case statements. Okay, switch case block. But for the if, we have one-way selection or single if statements. We have two-way selection, or what we call the dual if statements, and then we have multiple selection. Okay, so the one-way is an if statement, the two-way or the dual is an if-else statement, and then the multiple is an if-else if statement. And sometimes we have even nested if statements, which are also examples of what multiple selection statements. Okay, so we're going to take them one by one and learn how to construct them in C++. Okay, now before we go and tackle that, let's come back and then come and review. Last week, one of the things we reviewed was logical expressions. Okay, if you remember, logical expressions are any of the expressions or any of the operators which evaluates to true or false. So we have 6 of them in most programming languages. We have the equivalence operator, okay, which will tell you whether the thing is true, or sorry, whether the two things are the same. Sorry. We have the not equal to operator, which will be true if the two things are not the same, but false if the two things are the same. We have the less than operator, which will tell you if the first one is smaller than the second one, then it is true. Otherwise, it is false. We have the less than or equal to operator, which will be true if the first one is true, and then or the two things are the same. Okay. Then we have the greater than operator, which will tell you if the first thing that you are comparing is more than the second thing, then it is true. Otherwise, it is false. And then we have the greater than or equal to operator, which will also tell you whether the first thing is bigger than the second thing, or if the two things are the same, then it is true. Otherwise, it is what? It is false. So let's look at some examples. I know we already are conversant with this thing, but I just want to remind us because it is very useful here when we are doing our selection control statements. Okay, so for example, if I give you 8 less than 5, all you need to do is to check whether 8 is less than 5. Okay, now if you check, and we know from the number line and from our learning that 8 is not less than 5, and so the evaluation of that is what? False. It returns a Boolean. Whenever you see any of those 6 symbols, your understanding should be that the answer will be what? True or false. Okay? Then if we have 6 not equal to 6, remember I said that the not equal to operator returns true if the two things are not the same, but returns false if the two things are the same. So because 6 is equal to 6, it will return false because the two things are the same. Okay? Then the next one we are looking at is this one, 2.5 greater than 5.8. We know that 2.5 is not bigger than 5.8, so the answer to that one is also false. Okay? Then next one we are looking at is 15 greater than or equal to 7.3. Now we know from the number line that 15 is more than 7.3, and so that answer is what? Is true. Okay. Then next one is what? 19 less than 21. So we know that 19 is smaller than 21. So the answer to that one is, hey, who is that? Who is that? Hey.
To inform you that
Oh,
calls are recorded for quality and training.
who's that? Oh. Okay. Then 19, okay, so this one will be true. Then 9 is smaller than or equal to 13.8. So because 9 is smaller than or equal to 13.8, we also return true. Okay, so I hope we remember this ones. We learned them last week. We just revised. We learned them a long time ago, but we revised them last week. And today I'm hitting on it because we are going to use them. I hope we are okay with it. Hello?
Yes, sir.
Yes, sir.
Yes, sir.
And then remember also the logical operators, okay? The logical operators, the and, or, and the not. We use them to combine these ones into complex operations, okay? So remember those ones too as well.
Okay.
So with that out of the way and that understanding that we need these operators for the operations we are going to do, because if statements and the switch case statement, they use true or false, then let's go to the single if statement, or what we call the one-way alternative structures. So the if statement in C++, the syntax for it is very, very, very simple. The syntax looks something like this. You type an if, and then you put the test condition inside a bracket, and then you can put the code which should be run when the condition is true, immediately under it like this. Okay? The code only runs when the test condition is true. So please remember, for the if statement, the code only runs when the test condition is true. Are we okay? Who are the people with the microphones on? Please, if you're not asking a question, turn off your microphone, okay? Okay, thank you. Okay, so yeah, so we test the condition, and if the condition is true, we run the code inside. Now, this is how we will write it in C++. Remember, and when we're doing structured program design, we wrote it as pseudocode. But here, this is an actual programming language, so it must be written this way. Okay, remember you replace this comment. This is just a comment. You replace this thing with what you want to put there. Okay, so I'm going to show you some example, and then we are going to write a few examples. Okay, so before then, let me explain the mechanism. So for instance, if we have an if statement, a single if statement, and let's say that we have a variable called number, and number is equal to 5. And then we are checking if number is greater than 0. We should do something. Maybe something is here in the code over here, okay? Now, what we need to take note of, or what we need to do, is that the test condition will be checked, okay? We'll check this one. So we are checking whether 5 is greater than 0, okay? So if 5 is greater than 0, and this one returns true, okay? If it returns true, then what the computer will do is that the computer will go inside the brackets and run the code that is inside, okay? Before continuing with the rest of the code. The computer doesn't stop when it runs this code. No, it continues with the rest of the code down here. Okay, so this is how this one works. Now, what if the answer to this is not true, but it is false? Okay, so what if the answer to this is not true, but it is false? Okay, so if the answer to this is not true and it is false, okay, then what the computer is going to do, for example, in this case where 5, you are comparing whether 5 is less than 0, the answer will be false, okay? So if the answer is false, then what the computer will do is that the computer, after checking this and making sure that the answer to this one is not true and is false, it will look at the end. You see the end of this, the beginning of this, okay? It will look at the end of it and go outside and run whatever is outside, okay? It will not run what is inside. So this is how the mechanism of this one works. Mr. Bernard Ajete. Mr. Bernard.
Yes, I was.
Be quick about it, okay?
Yeah, please. Yeah, you made mention that when there's a 2/, that's a comment. So I don't know. But you're saying that it will run the comments. Does it run comments as well?
No, the comment represents. You see, we said code. So the comment is just representing code that is there. Yeah, and we are using the comment to represent code. So if you put code over there, then it will run the code. Okay?
Okay, all right. Thank you.
But whether there is code or not, if it is true, the compiler will go inside to see if there's something there to run. Okay?
Thank
Hello?
you. Okay, please. Thank you.
Okay. Yes, so those are comments. They will not be run by the compiler. But you see, we've written code. They are representing code, the code you want to write. We are just using them as placeholders. Okay, I hope everybody understands that. Okay, it's just a placeholder, okay? It's just like how you do illustration when you're teaching mathematics. So here too, we're just illustrating, okay? Okay, so let's look at actual examples of this in writing. So first example, we have a simple if statement, which is comparing 20 is greater than 18. Now, if 20 is greater than 18, then what we want to do is that we want to print or see out 20 is greater than 18. And obviously, you know that 20 is greater than 18. So we are expecting to see 20 is greater than 18. I'll take us to the window and then we'll run the code to see for ourselves what will happen if the two things are not true. Okay, we'll run it and see for ourselves. Okay. Then let's look over here, down here to us. One other example. We can put the 20 into a variable called x, put the 18 into a variable called y, and still do the same thing, and it will work the same way because x is just a container containing the 20, and then y is just also a container containing the 20. So please take note of that. It doesn't have to be the raw numbers. You can have a variable in its place. Variable is just a container which contains the values. Okay, now let me switch to the editor. What was it? Okay, so I'm just gonna slow everything down so that please today I'm slowing down. I think I had some messages. I didn't speed up last week, but I'm slowing down even further so everybody can follow along. I want you to be able to program. Okay, so I want to even see if I can organize some tutorial for those of you who are having issues installing any of these things. Remember, I said that if you're having issues installing any of this, you can still use the online compiler. Okay, the online compiler is there, is free of charge. You can just use it. Okay, so you can open the online compiler and then use it. I am not using any of those other apps like the code blocks or the IntelliJ or any of those things because I'm using a MacBook and the platform is a little bit different when you are installing some of those things. Okay, this is much more simpler to install on the Mac. Okay, so everybody can see my code, right?
Yes.
Hello, can we see my code? Okay.
Yes.
So
Return.
we are just going to do a simple exam. Remember, I said that if you want to type an if statement, you type the if lowercase. Remember, lowercase. Don't type capital I and then small f. It will not work. Okay. Then you type the how do you call it? The brackets. Please don't mind this tool. Okay, it's a tool which is doing that. Okay, don't mind it. Then we want to compare. We want to compare 30. Let's say 34 is less than maybe 18. Okay. Then if this is true, we want to see out. Okay. We want to see out 32 is less than 18. Okay. 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 So we have a simple, everybody can see the simple code I wrote. Very, very simple. Okay, I'm going to just copy everything and then paste it in the chat so that those of you who are following, those of you who are following can just copy it and paste it in your editor and then run it. Remember, I said that all the code will also be on the LMS as well, right? I want to create a folder on the LMS where I keep adding all of the code so that you can just go there and download it and then run it. Okay. I hope it's helpful. Okay.
Yes, sir.
So you see this simple one. Now let's check it ourselves to make sure that the compiler will not give us any wrong answer. So let's check. Remember, the most important thing here is this thing, which is the condition. So is 32 less than 18? Yes. Is 32 less than 18?
No, sir.
No, sir.
Okay. let me just put something here so that we know that it's the outside. We are outside. Okay. So 32 is not less than 80. So because 32 is not less than, oh, come on. So because 32 is not less than 18, we are expecting that this will be false. And because this is false, we will not run line 5. Line 5 will not run. So you are not going to see 32 is less than 18, okay? But instead, you are going to see it's going to continue because the program has not ended. There's also line 7. So line 7 is going to run, okay? So let's remember to save it. Well, C++, you have to save everything. So save it before you run the code. When you run the code, let's see what will happen in the editor. All right, so compiling the code takes a little bit longer because it's C++ is compiled, okay? So when it finishes compiling, you will see the answer, okay? So currently, what are you seeing, okay? So are we seeing 32 is less than 18? Let's go and look at what we are seeing down here, okay? You look at the output window down. Oh, I think, let me use the red, okay? So let's look at the output window over here. So look at the output window. What's it showing? Hello? Which of the two statements are showing? Is it statement 1 or statement 2?
Statement 2.
Statement 2. Because 32 is not less than 18. Okay? So for the if statement, it will only run the code inside if the condition is true. Okay? But if it is not true, then it will go outside and go and run whatever is outside. And all the code outside. I intentionally put this here so we can see it. Else we would not have seen any answer or any results. Okay, I wanted us to see the results. Okay. Any questions about how this one works? Then let me change it, and let me just change it first, and then let me show you what happens if it is not true. Okay. Okay. So if it is not true, okay. If it is not true, and we save that, and then we run that. Sorry, if it is not false and it's true, and we run that, let's check the compilation. It recompiles. Okay, so it recompiles, and you see that we have how many statements? We have 2 statements. Because now it is figuring out that 32 is more than 18 is true. Okay, so because it is true, it will run this code inside. But that's not the end. Okay, when it runs the code inside, it has not finished. It will go outside as well and run all the other code. Okay, so including this one. And return 0, which means to end the program. Any questions? I think this one is very simple. Okay, these types are very simple. Okay. Any questions? Okay. Let me show you another thing people normally would do. Let me close this side. Okay. Another thing people normally would do is also to create a variable. So if you create a variable and we say that you are 25 years old and we want to check for eligibility of voting, we know that in most countries it's 18 years that people vote. Okay, so if age is greater than or equal to 18, then we can say that you can vote. Okay, so let's say you can vote. Okay, and let's leave the statement as it is. Okay, so people normally also do something like this. Okay, where they put the number into a variable and then use it for the test. Okay, because we know that 25 is more than 18, we're expecting to see you can vote and then to see what outside if statement. So if we run this, look at the results down here. Compilation takes same amount of time, okay? All the time. Every single time you compile, it will redo the same thing again, okay? So you can see this, okay? Everybody can see you can vote, and then everybody can see the outside of if statements, because you can vote is true, and then outside of if statements is after the if statement. Okay? Any questions?
Yes, sir.
Yes or yes?
Sir, please. Hello, sir.
Pardon?
Sir, please, can we still round the else statement after the if statement?
Oh, one by one. We are doing it one by. We have not gotten there yet. Calm down. We are doing it one by one. Okay.
Okay.
Uh-huh.
All right.
One step at a time. Yes. So no questions about the single if statement. Okay. So I'm going to ask you for us to write a simple single if statement program. Okay. So we want to write a program which will check whether a number is zero. Sorry, whether a number is positive or negative, but we want to use if statements. Who can help me? Want to write a program which will check whether a number is positive or negative. If I give you this as homework, you go and use ChatGPT. So I just want to ask you here so that you can tell me. I'm going to mention names. Let me see the names. Okay, let me mention names. So remember, listen to me carefully. We are writing a program to check if a number is positive or a number is negative. Okay? So what do we do to write such a program? Remember, we will take the number from the user because we have learned C in, we have learned C out. So I'm going to just randomly choose someone and then ask the person to start the program for us. Remember, we will do input, processing, and output. We will do all the three phases of the input, output, input, processing, and output framework. Okay. So God's way, Ado, God's way. Can you hear me? God's way. Hey, is he gone off?
Yes, sir. Yes,
So
sir.
how do we start our program? Yes.
As a first, we'll create a variable.
Thank you very much. So God's way, that's all I need from you. Just give me one answer. We'll create a variable. So we'll create a variable called, let's call the variable called number. Okay. What's happening? Okay. So let's create a variable called number, which is an integer. And then I know Eric. What do we do next? This AI. Okay, I know Eric. What do we do next?
So we'll write C out, then we'll enter the first number.
What do you call that statement? We learned it last few weeks. Yes. What do you call a statement like that, Mr. Ano?
Okay, so
I know what you're
that
talking about,
statement
but I
is
just want to know whether you know what you are talking about. Yes. What do you say? It's called a prompt. Mr. Ano. It's called a
okay,
prompt.
sir.
So you do
Yes,
a
sir.
prompt, okay?
Yes, sir.
You said you want to enter a number, okay? Okay. Then let's call someone else. This time around, a woman. I think Magdalene Annan. What do we do next? After doing the prompt, what do we do next? Magdalene Annan. Hello? Is she there? Okay, I think Magdalene just is on the call, but she's not there. Millicent Opoku Mensah. Hey, all the women are on the call, but they are not in the call. Priscilla Adamali. I hope I pronounced it correctly. Priscilla. Hello. Priscilla. Wow. All the women are not answering our Okay. Who's talking? Millicent. Okay, Millicent is on. Okay, Millicent, what do we do next? After the prompt, what do we do? Oh, Millicent, we can't hear you. Can someone hear her? Millicent, can you type what you are saying in the chat? Okay, type it in the chat. We can't hear you. I can't hear you. Okay, please, we are on a timer. Okay, so please, okay, so let's choose another person. Priscilla, is Priscilla there? There's Dorcas Ametepe.
Hello.
Yes. So what do we do after the prompt? What do we do?
You type scene.
Thank you. So we take the value of the variable from the user. Okay. So that's very nice. That's very nice. Okay. And so let's call someone else. Alfred, Homer. What do we do next? We want to check whether the number that we've collected from the user is positive or is negative. We don't want to use if else. Okay, we want to use what we learned, the if statement. So we must write two if statements. Okay, so what do we do? Yes, Mr. Alfred. Mr. Alfred, are you there, or you also joined the call and left the phone? Okay, Ama Chirwa. Madam Chirwa. Okay, let me call my name. Bernard. There's one Bernard. Okay. Yeah, Alfred. Oh, I don't know what you're talking about, Mr. Johnson. I don't know. The example, we are not done with the example. So how are you running the example? Please take your time. Let's finish the example before you run the example, okay? Oh, my dear friends, why you are not talking? Henry. Mr. Henry. Hey. Can you hear me, or you can't hear me? Can people hear me?
Yes, we can hear you.
So is that they are deliberately not answering the messages, the calls for them to answer us? Okay, someone answer. Someone answer. Someone in the class answer, please.
If number is less than 0.
Thank you very much. So we just want to check if number is less than 0. Then what we want to do is that we want to. So don't. It's my co-pilot is doing that thing. Please forgive me. Okay. It's a bit. Yeah. So we want to do see out. Number is 0, right? Oh, sorry. Number is what? Negative. Okay. And then let's make sure that it doesn't budge against itself. Okay. Then what do we do for the positive? Yes. Who's answering the other one? The positive.
If number is greater than 0.
Thank you very much. So that one too, we will go if number is greater than 0. Okay. Then you will see out number is positive. Okay, so very simple. Yeah, thank you very much. Very, very simple. Let me, it should run perfectly well. Okay, so if we save that and we compile that.
Hello, sir.
Yes, sir.
Sir, so with this one, can we add if number is equal to 0, then the number is
Yes,
0?
you can add another one. You can add another one, right? That's perfectly fine. Okay.
Okay.
So 12 is positive, so you can see 12 is showing over here, right? Everybody can see, right? Let me rerun it again. So look down here. Do you see down here? It's asking us, the prompt is asking us, okay? Then give me a number. Somebody give me a number we can enter.
19, sir.
Oh, 19. Okay, no worry. So 19 is positive. Okay, so we are expecting to see positive. So you can see the answer, right? You can see the number is positive displayed over here, right? Let's make sure it works for negative numbers too as well. So let's run it. This time around, we'll give it a negative number. Okay, when it finishes compiling, we'll give it minus 100. We know minus 100 is negative. When we hit enter, you can see that. Hello? Hello?
We can hear you.
Okay, that's good. Okay. So let me just copy this for you and then we continue, right? So all of this copy. So any further question, you just direct it to me, okay? And then we can continue, right? Okay. So going further, let's go back to the slide and then let's learn the other one. So we know that this one is suitable and it's okay, but it has its problems. The problems is that you have to do the if statement one by one. Okay. What if you want to check whether something is true, and then when the opposite is also not true or is false, you want to do something else. So that one is what we call the if-else statements or the two-way selection statements. Okay, so the if-else or the two-way selection statement is a very simple block. What it does is that we check the condition. If the condition is true, we do whatever is inside. But if the condition is not true, we do what is inside the else block. So that's how it works. We will do this one only when it is true, and this one only when it is false. And then please take note of the syntax. So lowercase if, then the test must be a Boolean expression. It must be something that results in true or false. Then after you are done writing the statements in here, you write the else. And then you write the statements under the else for the false. So the statements under the if are for the true, and the ones under the else are for the false. Usually we advise that you do some indentation, okay? Indent your code so that it is easier to read and understand, okay? Now let me show you how this one, the mechanism of this one also works. So if we look at this if-else block, we see that with the same example, we see that when our variable contains the value 5, okay, the container contains the value 5, and we check whether the container, okay, we check whether the variable, we check whether the variable is the contents of the variable is greater than 0. Because 5 is greater than 0, we know that it is true. So when it is true, you see where the arrow goes, we go and do the code inside. We ignore this one. See, ignore this one. We go and do the code inside the if which is the true part of the statement, then when we are done, we continue with the rest of our code. That's how it works. Okay? But what if the condition is false? So if it is false and the number is still 5, but you see, we want to make it false, so we set the condition as 5 less than 0. 5 less than 0 is false. Okay? So because it is false, we totally ignore this one. We ignore the true part. And then look at the arrow. We go all the way around it to where the else is and run the code inside the else. Because that code is the code for the false. And when we are done, we continue with the rest of our code. Okay? So everybody understands the mechanism, right? I hope everyone understands the mechanism. So for the if else, we use it when we want to do something when it is true and another thing when it is false. That's when we use the if else. Something when it is true, another when it is false. And this is the mechanism of its operation. Now let's look at an example or two and then we'll go to the computer for some more examples. So in this first example, I have a variable called time. Time contains the number 20. Okay. Now, we are checking, is time less than 18? Okay. If time is less than 18, then what we do is that we print good day. Okay. We only print this when it is true, when this one is true. But if time is not greater than, sorry, it's not less than 18, it means it's greater than 18 or it is 18 and above, we print good evening. It means that this one is false. So in this circumstance, when time is 20, we are going to see good evening because 20 is not less than 18. And so we will go from here and come and print whatever is down here. Are we okay? Do we have a good understanding, my friends?
Yes,
Yes,
sir.
sir.
Okay, thank you very much. Another example, look at example 2. Let's look at the example over here. So in this example, we have a variable called number. And then we prompt the user. This is called a prompt. So we prompt the user for a number. Okay? Then we take the number from the keyboard or from user inputs. Okay, so now whatever the user has typed is inside the variable called number. It's the same program we did earlier. But remember, earlier one, we did it with 2 if statements. One to test the positive, and the second one to test the negatives. But if we combine the 2 together, we can use an if else. Okay? So the if part will test whether the number is positive. And will only run if the condition we are testing is true. And then the else part is checking whether the number is negative and will only run if the condition is false. Okay, so over here, for example, if the user entered the number maybe 13, okay? So 13, because 13 is greater than or equal to 0, we are going to run what is inside the true. And so we'll see positive integer entered 13. Okay. Now, what if the user entered number, let's say, -7? So when the user entered -7, because -7 is not less than 0, the program will go and run what is inside the else block, which is these 2 statements over here. Is it understood, please?
Yes, sir. Yes, sir.
Okay. I think I have another. Okay. Before that, let's run some examples on the.
Hello, sir.
Yes, sir. Yes, sir.
Sir, please. So, is it compulsory for the C out always to be positive?
I don't understand. What do you mean by positive? What do you mean by positive?
During the second example, if number is greater than or equal to greater than equal to 0, C
Yes.
out is that place. I didn't get it well.
I don't understand what the confusion is, but it's because of your question. I don't really know what you are saying. Are you talking about this
I am talking
text?
about yes, sir. Yes, sir.
Oh, but when a number is greater than 0, it is positive. When you write the opposite, which is when you write less than or equal to 0, then obviously you can't put this positive here. You have to swap the positions.
Okay.
Do you understand? Because if
Yes,
a number
please.
is greater than or equal to 0, you can't say negative integer. Oh, come on. Cannot do that. So
Okay.
you, the programmer, you have to write whatever is here based on the test you have done.
Okay.
So
All
at
right,
this
thank you.
particular or at this instance, based on this test done, if this is true, it means the number is more than 0. Okay, then it means it is positive. That's why the positive is starting.
Okay. All right, thank
That's
you.
why the string. In fact, it's just a string. Actually, just a string. Okay, you see the quotes around it. It means it's just a string. We can change it. We can do anything with it. Okay.
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 Thank
So
you.
that's that. Let's all go to the text editor, and then where did I place that? Okay. So everybody can see the text editor now. Okay. I think we'll get another example. Okay. So do the hash include stream. Okay. 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 So let's do a simple example. Okay. Let's create a variable called age. Okay. And then we'll do a prompt to ask the user to enter their age. Okay. Please remember that you need a prompt. The prompt is important. Okay, because the prompt is important because C++ is not a visual language. Okay, so you need the prompts so that users will know what you want from them before the cursor will start blinking without asking anything. Okay. So the next thing is to see in. Oh, sorry. The next thing is to allow the user to enter age. So once we have the age now, we want to design a simple program that will ask the user for their age and then determines whether the user is the user is eligible to vote or not. Okay. So if age is greater than or equal to 18, then what we want to do is to see out you can vote. And line. Okay. Okay. Think. Yeah. And then remember we are doing if else. So let's see out. You cannot vote. And then yeah. So everybody can see the program, right? Too big. Okay, everybody can see, right?
Yes.
Okay, so let's go through the program together. So it's a very simple test. It's just testing. So we create a variable called age, and then we have a prompt. A prompt is a message for the user, okay? So we are asking the user to enter your age, okay? Remember, it's a string. You have to put the quotes around the prompt. Very, very, very important, okay? Then cin allows us to take some values from the keyboard, okay? Remember, the age variable is an integer variable, so it means we can only take integer values, okay? Then we are checking. So we are checking a condition. This is a block that checks whether something is true or whether something is false. Okay. So we have the if and then we have the else. Now, what are we checking? We are checking if age is greater than or equal to 18. If age is greater than or equal to 18 is true, then we print you can vote. But if age is greater than or equal to 18 is not true, we print you cannot vote. Okay, so here, and that's what this program is supposed to do. So we are going to run it so that we can all see the results. But if there are any questions about anything I did, kindly draw my attention. I'll try and answer as best as I can. Okay, so let me reduce the size a bit so we can see everything. Okay, and then let's save that, and then let's run that. Let's run the code. So when we run the code, sorry, I cannot increase the size of this one down here. Unfortunately, I'm so sorry. Okay, I've tried severally to increase the size, but it doesn't work like that. Okay. So the code has run or compiled. You can see down here, right? Please look down here. You can see down here successfully compiled, and it's asking us to enter the age. So let's say your age was maybe your age was 58 years old. So when you hit enter, because 58 years old is greater than 18, you should see you can vote. Okay, so obviously you can see you can vote down here. Are we okay? If you want to run it again, you just right click in it and then rerun. So when you recompile, now this time around, we are going to enter something less than 18. We're going to enter something like maybe 16. And then when we hit enter, you can see the statement, you cannot vote, written boldly down here, you cannot vote, where the red arrow is pointing to. You can see that. Any questions? Any questions? So in any circumstance, you can use the single if statements, a lot of them, right? Single, plenty like that. Or you can use if else statements, if there are only two alternatives, true or false. Okay. But if the alternative is just only true, then you can use the single if statement. Yes, Mr. Ni Note.
Yes, sir. Can we do something that will display the you cannot vote and maybe red?
No, that's not programming.
All right.
That's not, C++ doesn't do that. Hello?
Yes, sir. Yes, sir.
C++ doesn't do that. That one is another programming language. C++ doesn't do that.
Okay, sir.
Okay, thank you. Okay, so like I was saying earlier, right? So if you only need to do something when it is true, then go in for the single if. But if you want to do something when it is true and another thing when it is false, go in for the if else statement. Are we okay? Very simple. Okay, I hope this one helps. Let's go back to the slide and then we will progress. Okay. I hope we are not going too fast. Okay. We're trying to make sure that everybody understands everything. Okay. Now, in C++, you often hear something called compound statement, or code block. So whenever you hear compound statement or code block, we're simply talking about a group of statements that have been put inside two curly brackets. The most important thing you need to do to form a compound statement is to start the curly bracket, put the statements there, and end the curly bracket or close the curly bracket. What it means is that this statement will run together. So far, I have not emphasized on that, but I need to tell you because where we are going, we will use this. Remember, we will use this often now, okay, to make more than one statement run together. okay, inside the if, and then later on inside the loops, okay? And then when we have functions too, we do it inside the functions. Okay, so please note that in C++, you can put some group of statements together to run together if you put them inside curly brackets. If you want a group of statements, you want to write, hello Bernard, how are you doing? Where do you come from? Maybe what are you learning? Or what are you teaching? What is today's date? You want to put all of that statement to run together. If a particular condition is true, then you just put all of those cout statements inside one big curly bracket like this. Okay, once you do it, once you do it like that, it's a block. It's called a block of statements or compound statements. Please take note of that. Okay, now let's see it in action. Okay, so in C++, it's perfectly normal to write the if statement without the curly brackets. You can see that here there are no curly brackets. Now, when you do something like this, what happens is that you can only put one statement under this one and only put one statement under this one. Okay, only one under each. This one is a simple two-way selection or simple if-else statement without the block, without the curly brackets around it. Now, this same structure or the same idea, if you want to write more than one statement under each of them, then you must put the curly brackets around them. Okay, sorry for the choice of colors, but I couldn't find any reasonable or legible colors for that purpose. Okay, so let's take note of this. So you see that this block starts from here and ends over here. What it means is that everything inside this part runs when the condition is true. Okay, so if I have 20 statements here, so long as age is greater than 18, all 20 will run. Okay, then look at this part, the else part. Everything here starts here and ends here. So what it means is that if this statement or if this condition is false, everything down here will run, no matter how many statements there are. Okay, so the curly brackets are very important. The curly brackets are used when you want to write more than one statement, or even if it's just one statement. In fact, we advise that even if it's just one statement, write it with the curly brackets around it so that you know exactly where it starts and where it ends. Is it understood? Is it understood, please?
Yes, sir.
Okay, very good. This one is not anything. It's just, I just wanted to emphasize it so that everybody here understands that it is important to put the code inside curly brackets, opening and closing curly brackets. C++ is very religious about those things. Okay. What's the, okay. Mr. Alfred said, I thought it was a question. Okay. Now let's go to the next block. Okay. The next one is called if else if statements. Okay. I think most of you are familiar with it already, but the programming is what I'm adding to it. Okay. So please focus on the programming. Now, the if else if statement, the logic is that now you can test if something is true and do something. Okay? You can test if something else is also true or false and do one thing when it is true and another when it is false. What if I have multiple things I want to check? Multiple things. Okay? What if I want to check whether a grade is grade A, if it is between maybe 80 and 100, or is grade B if it's between maybe 70 and 80, or is grade C if it is, you see, if you have multiple things you want to check, you can use single if statements, but there'll be plenty. You can use if else statements, but you have to do what we call nesting. You have to put statements inside those statements, okay? But if you simply do a block that tests multiple things at the same time, then we go in for the if-else statement. The if-else statement checks a set of alternative test conditions and then chooses only one that is true or runs the first one that is true. Okay, so if you look at the syntax in C++, it looks something like this. We have the if, remember, we have the condition 1. Because there are multiple conditions, we have condition 1. Then the statements that will run if the condition is true. If this condition is not true, notice that we have the else, but here we have the else if. You follow the else with an if. Please take note of that. You follow the else with an if. Then you write condition 2. Okay? So the statements that run when you, the statements that follow is the condition 2. Then you write your block when the first one is true, when the first one is false, and this one is true, you run this one. Okay? Then you can have another else if. You can have several else ifs. There was not enough space, so I couldn't put all of them there, but you can have several else if blocks. Before or afterwards, then you have what we call the else block. Okay, the else is optional. Okay, when none of these conditions are true, we come and run the else. Okay, so the else is optional. So please take note of that. Okay. Now let's see it so that we can learn it by seeing it in action. Okay. So how does it work? How it works is that, for example, if the condition 1 is true, how does it work? So we have a variable containing the number 2. Then we are checking, is 2 greater than 0? Because 2 is greater than 0, remember, it is true. So we come and do the code that is inside. When we are done, we go out of the block. Please remember, when we are done, we only do what is true and go out. Once we find something to be true, we do it and then we go out. Please remember that. Okay? What if the first one is not the true one and the second one is true? So this is what happens. So maybe, for instance, we set number equal to 0. Okay? And we check is 0 greater than 0. We know that that's not true. Then we go to the else if, which is the alternative. Okay, so we check is 0 equal 0. It is true, so we run the code inside. When we are done running, we don't go and do any other thing. We go outside and then we continue from there. So remember, once we find what is true, we do the code inside the block and go outside the entire if statement. Okay, so please take note of that. Now, what happens if nothing is true? So, for example, if the number is equal to -2, -2 is not more than 0, -2 is not equal to 0. So it means all these 2 are not true. So if you added an else, then that is where the else will run. And then when it finishes running, it will go to the rest of the code that you have in your program. I hope we all understand this mechanism. Do we all understand this mechanism? Or is there a
No.
question?
Please come again.
Pardon? Your audio is not too clear. Hello?
We don't understand everything.
You said you can't download everything?
Honestly,
There are safe statements. No, if you can like recap over that, please.
Okay. So let me repeat what I just said. I said that, for example, let's go back. So this is the same thing we learned in the structured program design. Okay, same thing. Okay, but here we're using a programming language, C++. So the syntax is what is important. The idea is that you want to check multiple things and see which one is true. Then if you find something that is true or the one that is true, you run the code inside. Okay, so we have the blocks. The block is written like this. You have the if, then you put the condition, then you put what is true. Okay, if the first condition is true, into a block. Remember a block, if I say a block, you know what a block is now. Okay. Then you have else if. Please remember, don't type if else. It will not, it is wrong. Okay. You type else if. Else if. Okay. Then you put condition there. Then you write your block. Then you can type else if condition block. Else if condition block. So you can type as many else if conditions and blocks as you want. Okay. Now, when you are done with all of this else if condition block, else if condition blocks, you can choose to add an else clause. The else runs if none of the test conditions are true. When none of the test conditions are true and you still want to do something, you can put that something inside the else block. Okay? Now, I was just explaining how it works. Okay? And here I have an if-else if statement which has 3 blocks. Okay? So we have the first block, the if statement over here. We have the else if statement down here. Then we have the else statement over here. You see 3 blocks. Okay? Now let's see the first example. So in the first example, if the user entered number equal to 2, we are checking it too. So look at the condition. So because number is equal to 2 and 2 is greater than 0, it means this is true. The first if statement is true. So we go and run the code over here. When we are done running the code, we will just exit, go outside the if. Don't run any other thing inside the if. After finding what is true and running it, don't run anything, go outside. You understand that one?
Yeah.
Hello?
We understand now.
Okay. Then let's look at the second one. So second one, very similar. Here, the user entered number equal to 0. So we know that 0 is not equal to 0. Sorry, 0 is not greater than 0. Okay, that one is false. Everybody agrees?
Yes, sir.
Then we go to the next check. The next check is the else if. So we check, is 0 equal 0? Yes. 0 is equal to 0. So we run the code inside. Remember, because this is not true, we skip it. This is skipping. We skip it and come and run the code inside. When we finish running this code, we exit from the if statement. Remember, I said the if statement, the rule is that once it finds the if-else if statement, once it finds the answer, runs the code, it will exit. It will not run the rest of the code. Is this one too understood?
Yes, sir.
Okay, thank you very much. Now, last one, what if the user entered a number like -2? And we know -2 is not greater than 0. So this one is false. Everybody agrees. At least everybody agrees with this one. 2 is not greater than 0. Okay? And -2, is not equal to 0. Okay? -2 is not equal to 0 as well. Okay? So because none of these tests are true, and we have an else, we go and run the code inside the else. When we are done, we exit the if statement. Remember, I said that the rule is that once we find the answer and we run the answer, we exit. We don't continue. Any questions? Any confusion? Still?
Hello, sir.
Okay.
Hello, sir.
Yes. Please be quick.
Is this if-else if statement an example of the block code? Compound, is it compound?
You totally misunderstood what I said about compound. I said compound statement is not, it's just code that we put inside curly brackets. That's all. We are learning decision control structures or decision control statements. So if else if is an example of a decision control structure. However, every time you put your code inside curly brackets, it is inside a block. It means everything inside will be run once the condition is true. Block is not an example of an if-else, or if-else is not an example of a block code. It's just when you put your code inside the curly brackets. You totally misunderstood what I was teaching. When you put your code inside the opening and the closing curly brackets, we call that code in there a block. Okay, you can put anything inside curly brackets. Anything. You can put if statements in there, you can put cout statements in there, you can put while loop statements in there. It doesn't really matter. But once the whole thing is inside the two curly brackets, it will run together. I only emphasize on the block because we use it when we are putting statements together. The gentleman who asked me,
Yes, sir.
perhaps you need to go and re-watch the video. Maybe you did not understand what I was teaching. But I hope we are all mostly okay with the explanation of the if-else if statement. That is what is important here at the moment. Okay, so let's do some examples before we go and run the code, okay? So first example, let's look at the first example over here. So this example over here, I have a variable called time, and I put 16 inside that variable. Remember, 16 is a whole number, so that's why I need the int, okay? Then I'm checking, is time, remember in a day we have morning, we have afternoon, and we have evening, okay? Now when the time is not 12 o'clock, we say, oh, good morning, okay? And when the time is not 6 o'clock, or I think in Ghana, 5 o'clock, people even greet good evening. But let's just say when the time is not 6 o'clock, it is good afternoon, okay? Good afternoon. Okay, here we are just going to say good day, okay? Anything which is not any of these two will be good evening, okay? So here, what are we doing? We are checking what is inside the variable time. Is 16 less than 12? No. So because 16 is not less than 12, we skip this one and go here and go and check the next one. And we check, is 16 less than 18? Yes. 16 is less than 18. So we greet or we see out good day. Once we see out good day and we are done, we skip the rest of the code. Or we skip the rest of the if statement and we go and do something else. Are we okay?
Yes, sir.
Okay, let me test whether we were following. And perhaps maybe some people are seeing something else. What happens if the number is 21? Is this true when the number is 21?
Yeah, it's true.
Huh?
Sir,
21 is
no.
less than 12.
No, it's
Hey,
false.
No.
It's
who was
false.
that?
Oh,
Who was that?
yeah,
Who
pardon.
said
It is.
true? Hey! Please, it's false. It's false. It's not true. It's not true. How about this one? Is it true or false?
False.
That's
It's
false.
also false.
False. Okay, so because the two things are all false, we come and run the else, which is what? Good evening. Okay, so when you see 21, 21 is 9 o'clock. Okay, 9 o'clock is evening. So, voila. Is it understood? Please, aside the person who said 21 is less than 12, everybody understands what we did, right?
Yes.
Yes, sir.
Thank you very much. Thank you very much. The gentleman who said 21 is less than 12, please see me after class. Okay? Then let's go to the next example. Next example, let's check. month, we have a variable called month, and we are checking if month is 1. If it is 1, you print January. If it is 2, you print February. If it is 3, you print March. If it is 4, you print April. If it is 5, you print May. If it is 6, you print June. Okay? Now, everybody knows that month cannot be more than one number. Okay? Everybody knows, right? This month is the 7th month, so you cannot say 7, 6, 5. You cannot do that. So what if we set month equal to, let's say, 4? What happens? What happens is that the computer will check, is 4 equal 1? No. Is 4 equal 2? No. Is 4 equal 3? No. Is 4 equal 4? Yes. So we will print April, and then we will go out. Please, I'm very much emphasizing on go out. Very important to me. Okay? After finding the correct answer, go out. That's how the if works. Please have it at the back of your mind. The if, after finding the correct answer, we stop. We don't continue the if. No. We go out and go and run the rest of the statements. Okay? Let's, Mr. Ajete. Yes, I'm all here.
Why is that you didn't end it with the else? And so that in case maybe you print out maybe 13 and it's not part of it, it will show that maybe it's not, it's not a
Mr. Ajete, I
month.
did not end it with the else because I want you to also know that you can write it without the else. If I only write it one way, everybody here will think that that's the only way to write it. And somebody will say, "Sir, but you didn't add the else," and they will think, and I would end up not teaching you. I want to teach you, so you have to write it in different ways so that you know that you can write it in different ways.
So in a case whereby the person inputs maybe a number that is not inside, what to print out?
What somebody answer him? What do you think will print out if the person somebody? I was going to do that example, but I want to ask, what do you think will print out if someone enters a number which is not here?
Error.
Oh, what's error? Hey, come on, who's that?
Invalid.
Pardon?
Invalid.
What is invalid? There's no invalid over here. Come on.
So with what you have on the screen, you will not see anything.
Thank you very much, Mr. Gosway. Is it Gosway or Godwin? Gosway, right? Mr. Gosway is correct. Because you didn't add the number and the condition for it, and you don't have any message to indicate anything, the program is not wrong. Okay, the program is not wrong. You just didn't add the number, so nothing will be printed. It will not print error. It will not print invalid or any of those things you think it will print. It will just not print anything because nothing is there to cater for the number you did not write. Okay? So let's do that example. Let's do that example so that some of your friends. So for example, what if the number is what? 14. Okay? And we know 14 is not equal to 1. 14 is not equal to 2. 14 is not equal to 3. 14 is not equal to 4. Okay? 14 is not equal to 5. 14 is not equal to 6. So nothing will be printed. You only print when you have made provision for it. Okay? Or when you have the else, then you print the alternative. But if you don't add the else, nothing will be printed. That's the purpose of the else. The else is there so that if you don't have the number catered for, you take care of it. Do you understand? Do we understand? Hello?
Yes, sir.
Yes, sir.
Okay. So I think another example. Yes, I have another example before I go to the the text editor. Okay. So let's look at this example. So in this example, we create a variable called number. We prompt the user for the number. We collect it from the keyboard. And now we want to check three important things. We want to check whether the number is positive, if it is greater than 0. The number is negative, if it is less than 0. Or the number is just 0. Okay. So this is what we do. So for example, what if the user enters 25? Okay. So 25 is greater than 0. So we are expecting to see what? You entered a positive integer. Then after doing that, we will exit. Okay. We will go outside this if statement. Everybody agrees?
Yes,
Yes,
sir.
sir.
Okay, good. What if the person entered minus 11? Minus 11 is not greater than 0. Minus 11 is less than 0, and so we will print you entered a negative integer. Then after doing that, we will go out. Okay, so that's what will work. Okay. Now, what if the person entered 0? Even if the person entered 3 or 5 zeros, it doesn't really matter. Once it is 0, it is 0. Okay. Now, if the person enters 0, 0 is not greater than 0. Remember, 0 is not less than 0. And so, because these two are not true and there is an else, you will see you entered 0. You see that?
Yes, sir.
Pardon?
Well understood. I've understood that.
Okay, understood. That's good. So I want you to understand the else only runs what is there if all the conditions are not true. Okay, the else only runs what is there if all the conditions are not true. If any of the conditions are true and it finds the first true thing, it will run the first true thing. Okay, let's do an example in the code editor and then quickly come back and then come and do. Okay, so I'll create a file called example 7.cpp. Okay, let's generate the. Okay, okay, so let's do a small program which will take the marks. Okay. Okay, let's collect marks and then decide whether the person gets A, B, or C. Okay. Okay, this one is not important. Okay, so we're checking if the marks that the person got, if the marks the person got is greater than or equal to 100. Oh, sorry. So greater than or equal to 90, sorry. Okay. Or let's just do 80. Okay, 80. Then we see out grade A. Else, if the marks is greater than or equal to, let's just do 60. Okay. Then we see out grade B, else we see out grade C. Okay. So very simple. Okay. Let me just add another one. Okay. So that you know that we can add more. We can add more, as many as we want. Okay. Greater than or equal to, let's do 40. Okay. So here we have an if-else if statement. We create a variable called marks. We allow the user to enter their marks. We take the marks from the user. Then we are checking if the number we have is more than 80 or more, we print grade A, and then we go out, okay? But if the marks we have is 60 or more, we print grade B, and then we go out, okay? Or if the marks we have is 40 or more, we print grade C, and then we go out, okay? Let me change this. Let me change this to D, okay? Okay. Or then if the marks we enter is anything below 40, okay, that's where the else is, okay, because here anything above 80 means even if you enter 1 million, you get an A, okay. Because we didn't cater for anything below 40, then the else will kick in when we enter something below 40. We'll see grade D, and then it will run. Are you with me? Okay. So let's see. Okay. Let's see. So let's run the code and then enter something. Please remember to save it, and then you run the code. Okay. So when it finishes compiling, okay. So it's now asking us, please, those of you who cannot see it, look down here. Please look down here. Okay. This is where the output is showing. Okay. Okay, so we want to enter something. So let's say the person did the exam and got 85. So we know 85. Let's see, 85 is greater than, 85 is greater than 80. Okay. Remember, 85 is greater than 80. So the first one it sees is grade A. After writing grade A, it will go out. Okay. So it will not print any of the other ones. So we are expecting to see grade A and then nothing. So when we hit enter, notice that, look down here, we can see grade A, only grade A being printed. Okay. We can see only grade A being printed. You see that? Okay. It doesn't print grade B, even though 85 is greater than 60. It doesn't print grade C, even though 85 is greater than 40. So you please take note. It does not print all of them, even though the number I entered is greater than all of them. It only prints the first one and stops. Any questions?
No, sir.
Okay. Now, I think we don't have enough time to do the next section. So we'll do more examples, and then we continue next week. Okay? God willing, next week. Okay. Okay. So let's do another example. This one I'm going to ask you for I'm going to ask you for the code. Okay. Or if you have any question, please, you can ask me. Then as I type these things, we any question? Oh, let me share the code with you. Sorry, I forgot. Those who want to run it and see. Okay. Any questions before our time runs out? Where were we? Okay, I think I was listening to this one. Okay. Okay. Any questions? Any questions? Any questions? Okay. If you don't ask me a question, I'll ask you a question. Any question?
So, sir, can you test us with a likely examination question?
Oh, no, I cannot. I'm teaching the thing now. Learn the thing first before you. Oh, heroes. There will be some in the LMS, okay? But now let's just learn the thing and understand the thing before you focus on exams, okay? Exam is not the end of life. Okay, yes. Any questions? Okay. We want to check whether a number is divisible by whether a number is divisible by, okay, whether a number is positive or negative, and if it is positive, check whether it is divisible by 2 or 3. How do we go about it? First and foremost, we want to check whether a number is positive or negative. If it is positive, then we want to check whether a number is divisible by 3 or by 4, sorry, by 2, by 3, or by 4, or by 5. Yes. How do we go about it, my dear friends? What do we do first? Listen, I'll not mention names so that
You
people get scared.
initialize.
Pardon?
You initialize a variable. Int.
We should initialize the variable. Let's just create the variable first. Okay. So
Let's
let's create the
create
variable. Okay. Let's create a variable called number. And then let's ask the user for input. Okay. So we ask the user for input. Okay. Then we want to check whether the number is positive or negative. Please don't mind this thing. Okay. It's an AI. Okay. Don't mind it. Yes. So we want to check whether a number is positive or negative. Yes. How do we do that check? To validate whether a number is positive or negative.
So we'll use the if.
Pardon me?
We'll use if.
Yeah, so say it so that I can type it.
So if the number is greater than
so if
0.
Pardon? If the number
If number greater than 0.
Okay.
Then it will be positive. So then we'll first do the
See out.
I say don't mind this thing. Okay. Yes.
So yeah, when it's positive, we'll check if it's divisible, right?
Okay. Let's just do the negative first. So the negative next. Okay. Now, if the number is positive, then we want to run a check. Okay. We want to check if the number is divisible. How do you find if a number is divisible by 2?
We'll still use if. We have to
Pardon?
know the if statements.
What operator do you use to check for divisibility? Modulo arithmetic. Thank you very much. So you do if, okay, number is divisible modulo 2 equal 0, okay, then you can now come and do that the number is positive or even. Else, if, okay, so I'm working towards this example because the next thing we need to look at is nested if statements. Okay, so remember, nested if statements is when you put one statement inside another statement. Okay, are you with me? Let me reduce the size so everybody can see the code. Okay, so you can see that we have the first or the big if statement, the block. We have an if else block. Okay, the big one. You see the indentation? That's a big one. Then inside that one, you have another if else statement inside. When you put, and you can put as many as you want. You can nest them as many times as you want. Okay, we call these nested if statements. That's the next thing we are going to look at, and then we'll look at switch case statements afterwards. Okay, so God willing, next week, please join early so we can recap and then do the stuff we need to do. Okay?
Yes, sir.
Thank you very much. Please don't stop learning. Visit the LMS and then do what we need to do on the examples and the assignments and the reviews. Thank you.